All right, so we're going to continue with our handout problems. But before we do that, I would like to just remind you one of Maxwell's predictions about the speed of light was encapsulated in this formula right here. So C, which is the speed of light, is 1 over square root of epsilon naught mu naught. And if you remember from electricity and magnetism, right, epsilon naught is the electric constant, and mu naught is the magnetic constant. And what are they? So electric constant, or epsilon naught, which is vacuum permittivity, was what, 8.854, I believe, times 10 to the minus 12. And those are farads per meter. And the electric constant, which is vacuum permeability, okay, and it has to do with the transmission of light, right, in all three directions. So this is part of it. And that was 1.1256, I believe, times 10 to the minus 6. And these are Henry per meter. And in many problems in this chapter and beyond this chapter, you're going to find that they are using either 300,000 kilometers an hour or 3 times 10 to the 8 meters per second. And another one that's quite used, I would say, I believe, is 300 meters per microsecond. I'm going to double check on that, but that's what I remember right now. Okay, now what's important about the speed of light is the fact that this is valid in all inertial references. So in all inertial references. All right, so let's kind of move on to our first problem here. Okay, so you have a picture below that shows two balls moving towards each other. And essentially you can put each ball in one of your system of reference, right? Kind of like how we did here, if you think about it. And now the question is, hey, what is the speed and direction for each one of those balls? And you have two cases. So let's look at each case separate. So in a reference frame that moves with ball 1. So if you have a reference, and now you can use actually the Galilean transformations. I'm going to put one here so we remember. U prime of x equals ux minus v. And so we're going to kind of go carefully and look at what is happening. So the speed of ball 1, let me write this down actually. The speed of ball 1 with respect to the reference frame that moves with itself, with ball 1. All right, so you can even call it with a prime, or you can call it not with a prime, whatever you are comfortable with. So I can call this u1 prime is going to be equal to u1 minus v. So if we look here and we plug our numbers in, we get 6 minus 6, and that's 0. And that's normal, right? Why? Because in reference with itself, it has no velocity that you can read. All right, so now the second part is the velocity of the speed or the velocity of ball 2 with respect to the reference frame of ball 1. Okay, so the velocity, the speed of ball 2 with respect to the reference frame of ball 1. Okay, it's kind of like above. Then in this case, you will have u prime 2 is equal to u2 minus v. Well, if you look at these two, they go against each other, right? So if you set a positive direction this way, then the other one moves in a negative direction. So hence that will give you the correct numbers that you have to plug in for your velocity. So u2 is -3. Right, and then you have -6. since we took the positive direction to the right direction, towards the right, I would say. So this will give you a negative 9 meters per second. This will also give you the direction to the left. All right. Okay, so we have those. Now we're going to go to case B. It would be so great if you can participate here. Try to pause the video and try to figure out what is the speed of ball 1 with respect to the reference frame that moves with ball 2, right? Because that's what they are telling you here in part B, right? We did part A. In part B, in a reference frame that moves with ball 2. So in a reference frame with itself, it's probably going to be 0. But then the other ones will compose, and then we'll keep track of the signs. So without writing all the words I just said, we have to look at U1 prime, in this case, in reference to inertial frame that is in with ball 2 is U1 minus V. Same idea for the number 2. Except now we have to pay attention who is who. So in the first case, we're going to have 6 minus negative 3, right? Because our negative comes from the fact that this moves to the left. All right, let's continue here. So this becomes 9 meters per second, right? Minus, minus, a negative in front of a negative gives you that. So this will be to the right. All right. And then the other one better come out 0. So it's negative 3 minus negative 3. So that's 0 meters per second, which is to be expected. So in terms of the reference frame that moves with itself should be 0. Okay, so that's it for this video.